Matric paper 1, question 2. And this is all about sequences and series. So we're going to cover arithmetic series, quadratic series, and then geometric series. In order to answer the questions on the question paper, you would need to know which expression belongs to which type of series. Determine the expression in terms of n, d, and r. In arithmetic series, d will be the common difference. In quadratic, you will have d1 and you will have d2. d1 will be your first difference and d2 will be your second difference. And we would see how we're going to use d1, d2, or the difference in order to solve problems. And then in geometric series, you will have the ratio or r which you will be working with. You need to know, or you would also need to be able to determine Tn and n by using the general expression. So we will cover all of this, and that would give you a good basic understanding of sequences and series in order to answer the questions. So the second part of this would be sigma notation, and to work out some of sequences, but that we will cover in a different lesson. So if we sort out, or if we go through part 1 and part 2, you should be able to have a good understanding on how to answer the questions, or question 2 of the Matric paper 1. So let's go, and we're going to start with linear or arithmetic series. I just want to keep this in the corner here so that you can just keep an eye on where we are and what we need to know, and then we can just mark off. So this I will do for all of these, for arithmetic, for geometric, and quadratic. Okay, so for linear, so the first thing that we said was that we would be required to know which expression belongs to which type of series. So that would be the general expression. So the general expression for the linear or arithmetic series or pattern would be Tn is equal to a plus n minus 1, and that would be times d. The first thing is we're going to look at what each of these variables means. So if I have the first thing, arithmetic series is a series. Let me just write an example of an arithmetic series down. So let's say we have a series 2, 4, 6, 8, 10. Very simple series. So when we have this, on top we can write 1, 2, 3, 4, 5. This top line here represents n. So n would be the position of the series. So n could be 5, and that is the fifth position of the series. N could be 3, and that would be the third position of the series. This bottom part here, this bottom part, that would be Tn. And Tn would be the value of a certain position in the series. So in this case, Tn equals 10, and that would be for n equals 5. So Tn is the value and n is the position. Let me write that down. So Tn is the value and n is the position. Okay, so now we know what the general expression is, and now we know what Tn is and what n is. Tn is the value and n is the position. A would be your first term. So in this case, A would be equal to 2. D is the common difference between the series. In a linear and an arithmetic series, the difference would always be the same. The difference between 4 minus 2 is 2. 6 minus 4 is 2. So the common difference would always be the same. So that's how one way of distinguishing if it is, or one way of knowing if it is a linear or arithmetic series, if they don't tell you in the exam. So that is your common difference. Common difference. So now we know what Tn is, and Tn is a value of a certain position in the series. N is the position, A is the first term, and D is the common difference. Now we're going to go and see how we can determine D, and another way of writing the terms in a series. We're going to write our series again, 2, 4, 6, 8, 10. We said A be equal to 2, D also equal to 2 because that's a common difference. Tn is the value and n is the position. All of this will make sense in a minute. Another way of writing this series would be A plus D, A plus 2D, A plus 3D. Same thing, there would be our first term, so this would be N, and that would be Tn. That would be our second term, that would be our third term, that would be our fourth term. Now this is very, very important to know as well, because sometimes the value of the second term or the value of the fourth term isn't given, and then we would need to be able to use this in order to find out the value of the term, or in order to sort out or to determine the value of a term. But we will get to examples of that later, and then you'd see where we're going to use this. For now, it's important that you know that this series can be represented in this form as well. To determine D, so the common difference is equal to T2 minus T1, and that is equal to T3 minus T2, and so forth. So it will always be the term on the right hand side, and you subtract the term on the left hand side, and then you would get the difference. And we would look at examples of that as well. Now to summarize, we have said, let me just call up what we okay. To summarize, arithmetic or linear series. First thing, the general expression Tn equal to A plus N minus 1, and that's D. We'll see now how we're going to use that. Second thing is Tn is the value. So if we have 2, 4, 6, 8, 10, and we have 1, 2, 3, 4, 5. So that would be N. That would be Tn. So Tn is the value, and N is the position. We know what D is. It's the common difference. We know how to determine D, because D is equal to T2 minus T1. That's also equal to T3 minus T2. Another way to write this would be A. We write it in different color. Let's choose blue. A plus D, A plus 2D, and so forth. So that would be 1, 2, 3, same as that on the top. So that would be N, and that would be Tn. So we've covered the general expression. We're going to see now how we're going to determine the expression in terms of N. covered that. Determine D in this case. Common difference. And we're going to cover that now. Determine T in and in by using the general expression.